Find the elevation at station 2 plus 0, 0 in feet. In this problem, a sag vertical curve extends from point A to point C with a length of 800 feet. Line segment AB is tangent to the curve at point A and has a grade of negative 1.2%. Line segment BC is tangent to the curve at point C and has a grade of positive 3.1%. The elevation and stationing at point B are also provided. The equation for the elevation along the curve is y equals r over 2 times x squared plus g1 times x plus the elevation at the beginning of the vertical curve. In this equation, y refers to the elevation of a point on the curve. For this problem, we'll use the units of feet. The variable r refers to the rate change of the slope along the curve, which is in units of percent slope per station, where one station equals 100 feet of length. The variable x represents the distance along the curve in stations. Variable g1 is the grade at the beginning of the vertical curve as a percentage. We'll call this the approach grade. Lastly, elevation BVC refers to the elevation at the beginning of the vertical curve, and we'll use the units of feet. The problem statement provides the approach grade, which is the same as the grade of line segment AB, and equals negative 1.2%. The problem asks to find the elevation at station 2 plus 0, 0. The problem states that point B is located at station 4 plus 0, 0, and that the length of the curve AC is 800 feet, or 8 stations, in length. Now we can compute the stationing at point A to be 400 feet minus the quantity 800 feet divided by 2, which equals station 0. Since the problem asks to find the elevation at station 2 plus 0, 0, we now know that this is a point 200 feet along the length of the curve located at x equals 2 stations. We still have to solve for the rate change of slope and the elevation at the beginning of the curve. We can find the elevation at the beginning of the curve since the problem provides the elevation at point B, and since we know the stationing at points A and B, as well as the slope of line segment AB. The elevation at point A equals the elevation at point B minus the grade times the difference in stationing between points A and B. After plugging in the appropriate variables, the elevation at point A equals 30.2 feet, which we will equate to the elevation BVC. The last variable to solve for is the rate change of slope, which equals the grade change divided by the length of the curve. G2 and G1 refer to the slopes of line segments BC and AB, respectively, and the length of the curve, AC, is given as 800 feet, or 8 stations. This makes the rate change of slope equal to 0.5375% change in slope per station, or for every 100 feet. After plugging in this value for variable r, as well as the other variables we already solved for, the elevation at station 2 plus 0, 0 equals 28.88 feet. When reviewing the possible solutions, the answer is C.